Peter Wadhams, how you going?
I'm doing fine, thanks.
And you're in Turin in Italy, where there's a bit of a heat wave, but they're used to it there. I've been reading about heat wave issues in Greenland, and I was just looking at Greenland. I'm actually relatively new to polar stuff, so I'm sort of using this conversation as a learning exercise, if you like. But what I found was on Google Earth. Can you see my screen with the map?
Yes, that's right. That's okay.
Yeah. So you've spent some time on Greenland, I assume, over your career as a polar researcher?
Yes, quite a lot over the years, yeah.
Okay. And what I was reading, what happened recently was there's like a big melt event. So this time of year, you expect to see a lot of ice melting off Greenland, but there's a lot more of it this year. Is that the case?
Yes, everything has changed. In fact, everything has changed in the world, but Greenland in particular. It used to be the case when I used to go there in my youth that you never got melting on Greenland because the ice sheet has an elevation of about 4,000 feet,
Right.
And so when you're standing on the top of the ice sheet, you expect the temperature to be sub-zero all the year round.
Right.
Always has.
Yeah.
But now, suddenly, what started to happen is it warms up enough in the summer months to get melting. And now the entire ice sheet is in a state of melt during the summer. So you're getting huge amounts of waterfalls, streams, rivers. When you stand on the ice sheet in summer, it's not like being in a totally frozen polar domain at all. That's resulting in the loss of a huge amount of ice as meltwater, and that's causing an acceleration of global sea level rise. So
yeah,
it's
sure.
pretty drastic.
And this is a big piece of land. So I just looked at the see if I can find the toolbar. If I go and grab this thing here, this is something in the order of 2,500 kilometers from north to south, or on its long axis.
Yes.
That is a colossal. And you said it's around, did you say 3,000 meters? No, 3,000 feet. What's the altitude?
It's about 3,000 to 4,000 meters thick.
Right. Okay, so it's about 1.5 kilometers thick or thereabouts.
Yes.
Okay.
So it's in terms of the ice content, it's certainly the second largest island in the world of ice. It's just smaller than Antarctica, but it's definitely not beating.
Yeah. Okay. And am I correct to say that if hypothetically all of that ice melted, there's enough water in that ice on Greenland to raise global sea levels by around 7.5 meters? Is that right?
Yes, at least that, because there's some question about how it would happen if it did happen, because as the ice melts, the land changes its shape because the weight of the ice is holding down the landmass. So there'd be some change there, but we don't know how much it would be. So 7 meters is an estimate, but it might be more.
Yeah. Okay. 7 meters. That's incredible. And so there's an expression that I heard a while back, and I think it was the Prime Minister of Finland who said something to the effect of, if we lose the Arctic, we lose the world. So, and there's this sense that this part of the world is so critically important for a stable climate, and yet it is undergoing like really traumatic and dramatic changes right now.
Yes.
And I guess what I'm trying to do is just kind of get my head around that. And the word that I've got that just seems to describe those changes, or what the changes would lead to civilization, is chaos, really. Because we've had this extremely long, the Holocene epoch of relatively stable conditions that just now seems to have just flipped out, just like, things happening that had never happened before, in terms of the melt. And my understanding is also is that as the temperature difference between the polar regions, particularly the Arctic and the equator, the temperature difference gets smaller because it gets hotter up there. That you lose the stability of all of those big energy balances, like is it the Rossby waves and the big circulations of air, which basically keep the cold in the north.
Yes, that's true. I mean, that's the big effect which has been noticed since about 2005, something like that, that suddenly people started to see these extreme events going on, extreme weather events, which had never happened before. That is extreme cold spells, extreme hot spells, and nobody knew what that might be. But then the person who actually did some good research on it showed that, in fact, it is the fact that the air mass over the polar regions has warmed up faster than the air mass over the tropics, and the temperature difference is lower. So with the temperature difference being lower, the jet stream, which blows around the world based on being driven by that temperature difference, that slows down. Suddenly, we don't have a big jet stream blowing around the world. We have a lot of little broken up jet streams, each of which can interfere with the local climate and give you extreme heat waves or extreme cold waves. And there's no way out of that, unfortunately. There isn't. That's not something where we can fix it. It's something we're going to have to put up with forever.
Yeah. Okay. And again, you come up with that whole idea of the big wavy loops in the jet stream, which is allowing warm air to penetrate into the Arctic region and Arctic air to come down, and those loops can actually sort of park and basically leave these like extreme weather conditions for some weeks, potentially weeks. Right? Okay. And then of course we've got the ice. So you've got the sea ice, which in that Arctic region reflects a lot of sunlight away, and so the sea ice is now reducing. And again, just help me with the numbers here. I'm reading, I think, that if we lost all of the sea ice in the summer period, then the amount of additional heat that would be penetrating into the Earth system as opposed to bouncing off back into space is equivalent to 1/3 of the total energy budget, or some ridiculously large number like that. Is that correct?
Yes, it is, because with the ice gone, much more of the solar heat is retained by the planet because it's darker. Suddenly you have dark sea, dark land where you used to have ice and snow, and that produces a permanent effect again on the planet. Yeah.
And then of course, as the water heats up, and I was watching one of the videos that you were presenting and some slides that had it looked like a sonar of the seafloor that had it's the East Siberian shelf, Arctic shelf, ESAS, that was around 70 meters deep, if I remember correctly, but there was a thin layer of sediment, but below that you're saying kilometers of methane hydrates.
Yes, it's one of the biggest threats that the world faces, but of course it's not facing it. It's the fact that underneath the seabed in the Arctic shelf regions, that's the Siberian Sea and Lativ Sea, you have this very thick layer of sediment, 2 or 3 kilometers thick, which is not strictly sediment, it's actually methane dissolved in water to form a kind of compound called methane hydrate.
Yeah.
And that stuff it's okay, it stays there so long as there's something on top of it to hold it down. That's the permafrost, which originates in the last ice age. But once that permafrost starts to melt, all of that methane is going to start coming out. It's going to turn itself back into a gas and come out. And it's already doing that. We've already got nasty sonar pictures, which you must have seen, of huge masses of methane gas coming out and the fact that methane levels in the atmosphere are rising more rapidly than ever before is probably, the extra methane is probably coming from these Arctic sources.
Okay, and this East Siberian Sea is the area, is that correct, around here where I'm showing on the map?
Yes, yes, yeah. I'm not sure if I can point to it, but it's where you're starting from. If you follow round the Russian Siberian coast,
All the way
right
around
up
here.
to where it comes to an end. That's the East Siberian Sea at the top there,
Okay.
and then you've got the Laptev Sea, the Kara Sea, but all those seas, as you can see from the map, the odd thing about them is that the water depth is very shallow,
Yeah.
about 50 to 100 meters, and that allows the methane to come out.
Yeah.
Where you have deeper water, like in the center of the Arctic Ocean, then any methane that comes out doesn't actually get into the air, it dissolves again in the water.
Right.
But if the water depth is shallow, then you're in trouble.
Mm-hmm. And there's a concept called the I understand the clathrate gun hypothesis that says that conditions could be in such a way that you'll have this massive burst of this methane, that there'll be like this really rapid positive feedback. Is the concern that this stuff could go off like fast, or is this one of those just slow time thing that's just going to go on and on and on for generations?
No, I think it's possibly going to go fast, and this is one of those things where the climate, the sort of basic climate people are complacent about that as about everything, and don't realise this could happen very, very suddenly. And it's the fact that the permafrost layer that holds it all down is actually melting.
Right.
And once that layer is melted, or once the pressure of the methane underneath works its way through the overlying permafrost, then you've got, we don't know what it will be, but it would be pretty violent and quite immediate, that within a short time, maybe a year or two, the whole of this methane held in the sediments could come out.
Yeah.
And you get a gigantic obvious burst of methane, but also that would cause sudden warming of the whole planet.
Yeah.
The estimates are 1 to 2 degrees, which is well, in itself doesn't sound a lot, but if it all happens at once, it is.
Yeah, and so you add the 1 to 2 degrees on top of the 1 degree that we've already got, and then you're.
Yeah.
Wow. Okay, can we go to the other side of the planet, which of course we can do in seconds with this technology, down to the Antarctic, where obviously, so it's very different in the Antarctic, predominantly because most of the white stuff you see there is actually sitting on land and surrounded by ocean, as opposed to ocean surrounded by land. Is there some big fundamental difference in the way that this global heating is affecting the Antarctic versus the Arctic?
Yes, there seems to be. The Antarctic has been warming more slowly than the Arctic, and I think it's the modifying effects that of being surrounded by very deep ocean, stretching out to the edge of the world, and it's slowed down the amount of heating that's been happening in Antarctica, but it hasn't slowed it to zero. And one of the things that's been happening is that the most sensitive part of the Antarctic seems to be the ice shelves, which are where the ice sheet itself has sort of squeezed itself out so that it's sitting over water and the coast. And that is unstable, liable to break up. So we've had several cases of complete ice shelves breaking out on the Antarctic Peninsula, and now we've got a danger of an ice shelf further around the coast breaking out. So if an ice shelf breaks out, in itself, if the ice shelf was already afloat, it doesn't affect sea level.
Yeah.
But in fact, it does, because usually the ice shelf is tied to the coastline, and if it breaks up and moves out, then that affects the general global sea level.
Yeah. Okay. And so, and because of that, yeah, like you say, so we've got a deep ocean surrounding the ice as opposed to shallow seas on the periphery of a. And so is it safe to say that the southern hemisphere is just going to suffer less of the dramatic changes as a result of that sort of stabilizing influence of the Antarctic?
Yes, I think it's not going to be suffering less, but it will suffer more slowly. I think the effects, like the disappearance of ice shelves, are going to be just as dramatic in the end. The same amount of water is going to be released, the same amount of global flooding is going to happen.
Yeah,
but it will happen more slowly.
yeah. And is there in the atmosphere, is there actually a partial separation between the air in the southern hemisphere and the air in the north, or does it all just completely mix? So if you get the big burst of methane up in the north, does that immediately like spread around the planet, or does that basically stay up in the north there?
Well, it originates in the north, but it does spread around the planet, and there's some rather frightening global maps that you can see showing methane levels in the atmosphere, which you can measure very accurately now from satellites.
Okay.
And it's always showing that the highest level is in the north, in the Arctic. So that seems to be where the methane's coming from. But it does spread right around the planet, and so you do get an increase in methane level in the southern hemisphere as well.
Yeah.
But the north is the driver.
Yeah, and so methane, my understanding now that the total like radiative forcing of methane is around about a third of that of the total footprint of CO2. Is that correct?
Yes, it's been growing. This is it's been sneaking up on everybody.
Yeah.
We thought that that's other scientists, not me, Billy thought that methane had been conquered, and the fact that the methane level in the atmosphere reached a stable state about year 2000.
Yes.
And for 10 years, so it's just stayed the same. And we thought, oh, we've conquered it. But it wasn't clear how we'd conquered it.
Yeah.
We conquered it. And then suddenly started to rise again. And it's been rising very rapidly. And it's beginning to vie with carbon dioxide as the most powerful greenhouse gas.
Oh, this is so charming. And like hypothetically, if we were to, and again, it's just a crazy hypothetical, but it helps to put a frame. If we were to stop producing anthropogenic carbon overnight, I mean, hypothetically, that could happen through something like I don't know, huge sun flare that takes out power grids around the world. But if my understanding is correct, a significant, about half of the CO2 that we emit is absorbed through natural processes relatively soon. Is that right? So, through the tree growth and soils and ocean carbon sinks?
Yeah, about 40% goes into the ocean.
Right.
That's been diminishing recently.
Yes. Yeah. So hypothetically, if we were to stop burning fossil fuels, there would be the atmospheric concentration of CO2 would taper off because of those natural sinks.
Yes, gradually it would, yes.
Yeah, but that's not that's not like you're not going to see this. If we were to stop burning fossil fuels overnight, you're not going to see like this noticeable reduction in atmospheric concentrations of CO2. It's going to take a lot longer. Is that right?
Well, it's if we immediately stop using fossil fuels altogether, then of course the CO2 level would go down, but slowly, because CO2 stays in the atmosphere for hundreds of years.
Yeah.
But it would slowly go down, but that doesn't mean that the climate would cool down at an equal rate, because there's a big chunk of our climate change that is is called unrealized. it's
Okay.
it's you're adding CO2 to the atmosphere. You're causing driving force on climate, which is making it warmer, but that takes a while to develop. So for a while, you've got less heating than you ought to be having. You've got a kind of little bonus, but it only lasts for a while.
Yeah. And of course, there's this. I frame the climate problem as actually having three separate sort of issues. One of which is that we keep belching the heat trapping gas in the atmosphere. Secondly, that there is this massive stock of the greenhouse gas in the atmosphere in the order of 2 trillion tons or something, 1 to 2. I'm not sure how it's measured. And the third one, of course, is that you've got this massive buildup of heat in the system. And so all of this focus that goes on to let's reduce emissions is simply ignoring the other two parts of the problem, as though fixing the one part of the problem fixes it all, where it only fixes part of it. I'm stabbing around looking for some good news here, Peter, but you're not helping.
Well, if we could, the good news with which I usually finish my lectures is, if only we could take carbon dioxide out of the atmosphere, we'd solve the problem. It's no good just emitting less. That just means we warm up more slowly. But if we actually take it out, like air capture or ocean capture, reduce the CO2 level, we're on our way to doing better. So we must do that, but nobody's doing it. People are saying, doing little pilot studies of direct air capture, but nobody's saying, let's do this with all the power we've got and forget about anything else in the world. That's what we should do.
And so do you think there is a potential for, so there's, a couple of the ocean capture techniques, things like the mass planting of macroalgae and the iron ocean fertilization ideas. Do you think these have got hypothetically the capacity to actually significantly to draw like gigatons of CO2 out of the atmosphere, or is it just fanciful to think that they'd be able to scale up?
No, I think they could be scaled up. It's just people seem to be terrified of thinking about scaling up. I mean, it's been years since people have realized that we can take CO2 out of the atmosphere and just by scrubbing it out and dumping it somewhere. But it's only been done on a small scale. It's just sort of some little thing in Iceland. But we can remove a few thousand tons a year. We should be removing 40 billion tons a year. And then we'll be getting somewhere. But there's something wrong with, well, it's not something wrong with human race, because there is something wrong with human race, but it's to doing with the scaling and the refusal, really, of the people who should be putting all the money in, that's governments and big foundations, to actually do so.
And look, I was having a conversation with Dr. Peter Carter the other day as part of this interview series, and my framing of the sustainability crisis, what I sort of came to understand in 2016 when I was thinking, why is it that Western people are so accommodating of the political and economic systems that allow the biosphere to collapse, which is our life support system? It's a suicide mission. There's something sort of spiritually wrong with people, Western people or people en masse. And when I say spiritually, it's to do with like these big stories about why we're here and what are the things that we're pursuing as valuable in our lives. So the pursuit of wealth, the pursuit of power, the pursuit of consumerism, all of these distractions from paying attention to the fact that we're a part of a global ecosystem, and that whilst we're a natural part of that ecosystem, we came here in the same route as the trees and the bees and the whales and the snails. We've got the same sort of obligations here, which is to pursue our life interest in a manner that looks after the well-being of the host. There's something that's, for me, that was like a target area of a place to sort of try and inquire to see if there's leverage there as to, and I was in another interview today, and I made a quote, or I read a quote, I'm just trying to find it. It was from Fernando Cortez, who was one of the conquistadors that went over to South America. And he was explaining to some of these indigenous people that they were in the process of destroying. He says, "My men and I have a disease of the heart that can only be cured with gold." And I'm like, it's the same problem today across the whole system of power and dynamics in corporate world, in business, in government, is that nobody's paying attention to the ecosystem. And if we can find a way to trigger them to pay an interest in the ecosystem, then that's the pathway, like spiritually connect to nature, right? Then that is a pathway to changing behavior, because ultimately what we need to do, and this is from what I understand you're telling me, is that whatever it is, if we're going to do something on a grand scale, we need to do it really quickly. No more mucking around.
Yes. I mean, there's a book, very nice book about climate change, and I'm trying desperately to remember the author, saying that we deals with the kind of spiritual aspects of climate change. As well, we have a duty of stewardship towards the planet.
Yeah.
And that's what we have to do if we want the planet to survive. But it's certainly true that the mechanical things we can do. I mean, there's things we can do that are more spiritual, but mechanically sort of building something and grabbing it and putting things together and making them work, that has to be done immediately. And that's the removal of the direct air capture methods, dealing with CO2 in the atmosphere, or dealing with CO2 in the ocean, which apparently is cheaper. But we have to do it straight away. We can't just sit around thinking, oh, in 2050, we better get around to doing this. We have to do it now, and nobody's doing it.
They're going to get really busy in December 2049, trying to hit that deadline. Look, I just had my little 10-minute warning flag up. So what I'd like to do is to wind up in a minute, but maybe come back in a few weeks and just to have a little bit more. Is that all right? Because this is so valuable. Okay, well, let's just wind up. Peter, thanks so very much for taking the time. And we've got about a third of the way through my list of little things that can kill you in the polar regions. We didn't even get onto polar bears. Anyway, okay, let's talk in a little while, huh?
Yes, okay, fine. Yes, sorry I'm late for this one. But there was a climatic reason, that is to say, the street was jammed with cars, and at the same time, it's incredibly hot, so you can see the link between the two. I get it. All right, thanks, Peter, and let's talk in a while, huh? Okay, fine.
Bye-bye.